Assalamu students. Today's our topic is going to be about numerical of work and energy. Let us look at our first numerical. A man pulls a car through 35 meters applying a force of 300 Newton. Find the work done by the man. Now here's our car. Let me draw it for you. Let's say this is our car and a man is pulling it in this direction and he's applying a force of 300 newtons, and this car has displaced a distance of 35 meters. So how we'll solve this numerical, and we have to find the work done in this case. Now in this case we have S is equal to 35, that means displacement is 35. The force is 300 Newton. The work done we have to calculate. Simple formula, W is equal to F into S, or 300 into 35, or we can say 10,500 joules. That is our answer for work done. For the next question, a block of 20 Newton is lifted 6 meters vertically upwards. Calculate the potential energy stored in it. Now here's a block and it is raised to a certain height, let's say 6 meters, and it is of 20 Newton weight, which is acting in downward direction. Now what is the potential energy in this case? So we have the formula for potential energy, mgh, and we'll use that formula. Let's see. The solution is weight is equal to 20 Newton, height is equal to 6 meters, potential energy we have to find out. Formula is potential energy equal to weight into height, so we have 20 into 60, so 6, so it is 120 joule potential energy. Moving on to the third question, a car weighing 12,000 or 12 kilonewton has a speed of 20 meter per second. Find its kinetic energy. Now we have the weight, which is 12 kilonewton, and we have the velocity also, which is of 20 meter per second, and we have to find the formula for kinetic energy, which is equal to half mv square. So we have to look for the m. We only have the weight, so weight is equal to mg. From that we can calculate the value of m by putting w by g. Let's see how it is being done. W is equal to 12 into 12 kilonewton, or we can say 12 into 10 to the power 3 Newton. Velocity is equal to 20 meter per second. Kinetic energy we have to find out. M is equal to W over G is equal to 12 into 10 to the power 3 divided by 10, which is the value of G. So we have M is equal to 12 into 10 to the power 2. So it is 10 to the power 2 over here, not this one. Kilogram, we have kinetic energy is equal to half mv square. So m we have already of 10 to the power 6 into 10 to the power 2. So it is 10 to the power 2, or we can say 100 over here, and it is half mv square because half into 12 into 10 to the power 2 into 20 whole square. So it will be 2 ones are 2 6 are 6 into 10 to the power 2, or we can say the square root of 20 is 400. So that is why I have written kinetic energy is equal to 6 into 10 to the power 2 into 400. So the value of this whole thing will be equal to 24,100,000, or you can say 24,000 joule. Now, or we can say in simple words that 240 kilojoule, and that is our answer as well for the kinetic energy. A 500 gram stone is thrown up with a velocity of 15 meter per second. Find its potential energy at its maximum height, the kinetic energy when it hits the ground. Now we have a stone which is thrown in the upward direction with the velocity of 5 meter per second, and we have to find its potential energy and the kinetic energy when it hits the ground, and we have to find the potential energy when it reaches its maximum height. Now how can we do that? First of all, let us find the maximum height it has obtained in this whole procedure. So mass is equal to 500 gram, or we can say 0.5 kilogram. The velocity, initial velocity is 50 meter per second. Potential energy we have to find out, and the current energy we have to find out. First of all, we have to find the maximum height by which we have only the data, which is vi, the initial velocity, equal to 50 meter per second. Final velocity at the highest point, at this point it is going to be 0 meter per second, because it is going to slow down and then come back to the ground. The g has a value of 10 meter per second square, so it is not 2, it is square. So h is equal to, we have to find out. So we are using the third equation of motion, which says 2g h is equal to vf square minus vi square. It's nothing over here, vi square. Moving on, putting in the values 2 into minus 10 into h is equal to 0 square minus 15 square. So 20 into h is equal to minus 20, 220, because the square root of 15 is 225. Height which we have over here is 11.25 meters. Now students, we have the height. We can calculate the formula for potential energy is equal to mgh. So we have the mass, we have the value of g, and we have the value of h as well. So mgh is the formula which we are going to use to find out the potential energy. So it is 0.5 the kilogram, 10 meter per second square of the acceleration due to gravity, and 11.25 is the height. We have 56.25 joules, and it is going to be the same value as that of the kinetic energy, because energy can be converted from one form to another. So when the stone returns to the ground, this potential energy will change into kinetic energy, and it also has the same value, which is 56.25 joules. Moving on to the next question. On reaching the top of the slope 6 meters high from its bottom, a cyclist has a speed of 1.5 meter per second. Now here's the slope, and there's a cycle over here, and there's a cyclist over here as well, and it reaches to the top with a speed of 1.5 meter per second. Find the kinetic energy and potential energy of the cyclist, and the mass of the cyclist is 40 kilograms. So 40 kilograms multiplied by value of g, so it is going to be 400 newton, the weight of that cyclist. And we have to find that how much is the kinetic energy and the potential energy when its height with the slope was 6 meters. So height is 6 meters over here as well. Now the solution for this one is, we have the velocity, which is 1.5 meter per second, the mass is 40 kilograms, we have the height, which is 6 meters, kinetic energy and potential energy has to be found out. So first of all, let us find the value of kinetic energy. Putting the values half 40, which is the mass of the cyclist, multiplied by 1.5 into 10 power, not into 10 power, 1.5 to the power of 2. So we'll take half of this one to the 40, so half of 40 is 20, multiplied by 2.25, which is square root of 1.5, or square of 1.5. We get 45 joules is the kinetic energy of that cyclist. Now for the potential energy, we have the formula mgh. Putting the values of m, which is 40, the value of gravitational acceleration, which is 10 meter per second square, and the value of h, which is 6 meters. So we have 2400 joule, and this way we have to do the numericals, and our answer is also correct. Moving on to the next question, which is question number 6. A motorboat moves at a steady speed of 4 meter per second. The water resistance acting on it is 4000 newton. Calculate the power of its engine. Now we have to calculate the power. For that we have a formula. That power is equal to work done over time. Now over here we have given the speed. So W is equal to F into D. And if we put this value of W in this formula, we have E is equal to F into D divided by T. As we know, D over T is equal to velocity. That means displacement over time is velocity. So we have force into velocity is known as power. Now we will use this concept now. V is equal to 4 meter per second. So F is equal to 4000 Newton. T we have to find out. The speed indicates that it covers a distance of 4 meters in 1 second. So distance is 4 meters, time is 1 second, force is 4000 Newton. W is equal to F into S, so 4000 into 4, so it is going to be 16,000. So the power is going to be work done over time. So 16,000 divided by 1. So our answer is 60,000 watts, or we can say 6 kilowatts. And that is our answer. Question number 7. A man pulls a block with a force of 300 Newton through 50 meters in 60 seconds. That means there is a block over here. A man basically pushes it and applies a force of 300 Newton in this direction, let's say, and it covers a displacement of 50 meters, and the force is 300, we know that, and it took him 6 second time. Now let us calculate how much power used by him to pull the block. So the solution is, we have the force, we have the displacement, which is 50 meter per second, time is 6 seconds, and the power we have to calculate. And we have the formula for work, which is F into S, putting the values 300 into 50, so it is 15,000 joule. So divided by time, which is of 60 seconds, we have 250 watts. Question number 8 says, a 50 kilogram man moves 25 steps up in 20 seconds. Find his power if each step is 6 centimeter high. So here's our condition. A man is trying to move up the stairs, and there are 25 stairs. So from here to here, there are 25 steps. And height of each step is how much? Is 16 centimeter. So how much this total height will be? Yes, it will be 25 multiplied by 16. So whatever the answer, that is our answer for the height of these stairs, and he has to climb from here to the top position in certain amount of time. Now here he goes and he reaches to the top. Now let us calculate. We have the mass, which is 50 kilogram, time is 20 seconds. We have to calculate the power. First we find the height of that 25 steps, or 25 multiplied by 16, which is 400 centimeters. So from here to here, it is 400 centimeter, or we can say 4 meters. So in the next case, we are going to divide it by 100 to convert centimeter into meters. We have 4 meters over here, which is the height. So power is equal to work done over time. So work done is equal to mgh, where m is 50, the value of g is 10, the height is 4 meters, so it is 2000 joules, and that is the work done in this case. But what about the power? So work done over time, so 2000 divided by 20, so power is going to be 100 watts, and that is our answer as well. Calculate the power of a pump which can lift 200 kilograms of water through a height of 6 meters in 10 seconds. That means there is a pond over here, there is a motor which is pushing this pond to a certain higher pond, and motor is pushing all the water from the ground level to the water in the tank. So how much power is the motor basically applying? Let us calculate that. Now first of all, the height in this case is of, let's say, 6 meters. 6 meters. The water over here in this case is how much? 200 kilogram. And it all is being done in just 10 seconds. So we have to calculate the power in this case. The solution for power calculation is mass is 200 grams or kilograms, height is 6 meters, and the time is 10 seconds. So W is equal to mgh, that means work done in this whole case by the motor is mgh. So power will be mgh divided by T. So 200 multiplied by value of G, which is 10 meter per second square, plus multiplied by height, which is 6 meters divided by 10. So the power in this case is 1200 watts, and that is our answer as well. Now last question says, an electric motor of 1 horsepower is used to run water pump. A water pump takes 10 minutes to fill in an over tank. The tank has a capacity of 800 liters and height of 15 meters. Now the motor is over here, and the water level is pushing up from this pipe to a height of, let's say, 15 meters to a tank on top over here, and it is at the height of 15 meters, and the water is being thrown over here like this. Now in this case, we have to find the work done by the electric motor to fill in the tank, also find the efficiency of this motor. So we have to find the percentage efficiency of this motor as well. For this, we have to calculate the output as well as input. For this, we have the horsepower. 1 horsepower, we know that it is equal to 746 volts. Time is equal to 10 minutes because we have to convert that into seconds. So 10 multiplied by 60, so it is going to be 600. Write it down as 600 seconds. So the work done in this case is horsepower is equal to 740 watts. So work done is equal to power into time. So 746 multiplied by 600. So it is the work done is 447,600 joules. That is the work being done by the motor in just this time, which is 10 minutes. Now the efficiency of the system. Now what is the efficiency? The output divided by input multiplied by 100. So input is the motors which is applying, which is 447,600 joules. But how much is the total output? That means how much was the water being thrown into the tanker. So for that we have mgh, that means how much was the height, how much was the mass, and how much it basically threw the mass into the tanker. So it is 800 liters multiplied by, or you can say 800 kilograms into 10, which is acceleration to gravity, multiplied by height, which is 15 meters. So when we multiply it, we get 20,000 joules. So output over input multiplied by 100. So this is our output, and the 476.00 is our input. Let's see. So 100,000 divided by 447,600 divided multiplied by 100. So our efficiency will be 26.8%. That means that is the efficiency of the body. But here the values has to be calculated very precisely. That 26.8% is the efficiency of this motor which is pumping the water into the tank over here. I hope you understand today's lecture. Inshallah, we'll meet again in the next class. Allah.